now let's start with some question example which will make your understanding clear how we can solve this kind of questions. So now if this is the given function is given, find a question is find the point upon the plane ax plus by plus z is equal to p at which the function f is equal to x square plus y square plus z square has a minimum value, and find the minimum value of f. So if you read it carefully, they are asking us a minimum value of this function. So our first step is to find what is objective function and what is the constraint function. So मैंने पहले भी बताया था कि जिस फंक्शन का हमें अगर मैक्सिमा या मिनिमा जो भी निकालना है वो फंक्शन हमारा ऑब्जेक्टिव फंक्शन बन जाएगा. तो यहाँ पे जो लिखा है f इज इक्वल टू एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर, दैट विल बिकम आवर ऑब्जेक्टिव फंक्शन. एंड द कंस्ट्रेंट फंक्शन मतलब जो रिलेशनशिप दिया हुआ है एक्स वाई एंड जेड के बीच में जो भी रिलेशन है वो दैट वी आर गेटिंग फ्रॉम दिस इक्वेशन, दैट विल बिकम आवर कंस्ट्रेंट फंक्शन. So we will denote it by phi of x y z and f of x y z. This is the how I have found it. This is our objective function and this is our constraint function. So now we can apply the Lagrangian method to find maxima and minima. So as per the equation for capital F of x y z, that will be the addition of objective function and constraint function along with this lambda. You shouldn't forget about it, that's a Lagrangian multiplier. So I just put it the this value from equation 1 and 2 for these functions along and with this lambda also. This will become my equation 3. So this is f of capital F of x y z. Basically this will be your auxiliary function. So now further is once we get this function, the next step will be we have to find the differentiation again. Since this is the three variable function, x, y, z is there, we have to differentiate this f with respect to x, y and z. So here when this function which I received in equation 3, I have differentiated with respect to x, y के साथ किया एक बार और z के साथ किया एक बार. So concept of partial differentiation that will be same like if we are differentiating with respect to x, other than x whatever will be there those will be considered as a constant. So ये सारे y z जो भी है वो constant हो जाएगा, सिर्फ x स्क्वायर का डेरिवेटिव हो जाएगा, पार्शियल डिफरेंशिएशन हो जाएगा 2x और यहाँ पे भी x है तो इसका डेरिवेशन लैम्डा ए हो जाएगा. ये बाकी सारे टर्म जो y z जो भी है वो ज़ीरो हो जाएंगे. सो नाउ सिमिलरली इफ़ आई एम डिफरेंशिएटिंग विथ रिस्पेक्ट टू y पार्शियली, सिर्फ y का डेरिवेटिव निकालना होगा, बाकी x एंड z विल बिकम ज़ीरो बिकॉज those will be considered as a constant. y स्क्वायर का डिफरेंशिएशन टू y एंड यहाँ पे भी एक बार y की टर्म आती है उसका डेरिवेटिव हो जाएगा लैम्डा b. Now similarly del z, with respect to del z we will be differentiating f, so 2z plus lambda c you will get it. Other x and y will be considered as a constant. So ये तीनों वैल्यू हमने निकाली है. So next step will be we will be equating those equations to 0. क्यों नहीं करेंगे? To find the stationary values. So that will be our next step. So whatever value we got it in the previous slide for del f by del x, del f by del y and for del f by del z, we will be equating that to the 0 so that we should get x, y and z value which are nothing but the coordinates of a stationary point. So simply by rearranging these equations I will get x is equal to, I have rearranged the equation so that x value should be separate, should get it. X is equal to lambda by minus lambda a by 2, y is equal to minus lambda b by 2 and z is equal to minus lambda c by 2. So if you look at this all x, y and z values, you will see that each of this value is having lambda, which is Lagrangian multiplier, we say that. That is there, it is included that value. So one thing is clear, if you could find that value of lambda we will get x, y, z value in terms of like a constant. So now the thing is we have to find the value of lambda. So how we can find lambda of value of lambda is we have to use these values in the auxiliary function x y z जो भी हमने अभी निकाला है values x y z की हमें auxiliary function में डाल देंगे ताकि हमें उसकी lambda की value निकालें. So in the previous for auxiliary equation we have considered as the equation 2. That auxiliary equation was something like ax plus by plus cz. That was our auxiliary equation. So here in place of x, y and z, I have kept this value of x, y and z, which is from the previous step. So now after simplification I will get this 2 denominator is everywhere, so I will just shift it over there on the other side, and after multiplication this each a square minus lambda a square plus यहाँ पे से multiply करेंगे इसको इसके साथ multiply करेंगे, then you will see that lambda we can easily take it out common from all the terms. So this is what I have got it here. Now our iteration is we have to get the value of lambda. So lambda I kept it at one side, and other than that the term I have shifted on the right hand side. So here I got the value for lambda. Now this whatever value we have got it for lambda, we can keep it in the value of x and y and z, so that we will get the values which won't be having any lambda in that. So if you look at the previous slide, these are the values which we got for lambda, for x, y and z. In this case, whatever value we got for lambda, we will keep it in that, so that we will get values in terms of x, y, z value in terms of constant. So यहाँ पे मैंने in x, whatever value we got for x, that in place of lambda I have put it this one, minus 2p upon ab plus a square plus b square plus c square, and same thing for y and z. So this is how we now get rid from the lambda from the x, y, z's value. So now these are nothing but the stationary points x, y, z, the coordinates of x, y, z. So this is what we got it. Now what we have to do is we have minimum function, the function which we have got, they ask us to show the minimum value. That is nothing but if you look at the previous slide, we have to ax plus by plus cz, that's the function. So in this case x value, y value and z value we have to substitute here. So now after that, after multiplying with a with respect to each of these, then you will get a function which will be something like this. After adding all this term ax plus by plus z, इसकी जगह पे हर एक x, y की z value हमने substitute किया है. So if you look at the denominator, everywhere that denominator is common, so we can just go ahead and add the numerator. So p square, again if you see it's everywhere common in the numerator, we can pull that out. Rest of the term हम bracket में लिख देंगे उसको. Now simply we can cancel this bracket, one bracket will get cancelled, and then we will get the final value, minimum value, which will be p square upon a square plus b square plus c square. This is nothing but the minimum value of the given function. So steps are pretty straight like forward, which are we followed over there to find the maxima or minima for the two variable. Only thing is, after equating that del f by del x and del f by del y with respect to 0, with 0 those equations, after equating to 0, we have used those values in auxiliary equation, so that we should get the value of lambda, because then we will get x, y, z coordinates of stationary points purely in terms of constant values. So that is one additional step which there. Other than this whole concept, if you look at all the steps, it's the same thing what we did in the finding maxima and minima for two variable functions. So it's exactly same, other than that additional step. I hope you will find it easy if you will compare that, and if you will try to understand the difference, and if you try to keep it in mind, that clearly it will be much easy to solve the questions. I think that's the thing, that's how it is, Lagrange's theorem, how to implement it. Thank you.